Hello and good morning everyone. I welcome our prestigious lecturer Mr. Jale and my fellow friends. Today we will be presenting about a topic entitled Vector and Scalar. But before we present it, I would like to mention every section we have in our presentation. First, we have application of vector and scalar, which will be presented by Hafiz. Second, we have mathematical solution with drawings by Atira. And lastly, the conclusion, which will be presented by ID Zwandi.
Hello, my name is Muhammad Hafiz Muhammad Hazri. Now, I'm going to talk about application of vector and scalar. What is vector? In physics, a vector is a quantity that has magnitude, the measurement of the size of an object as well direction, also an indication of position. Example of vector are velocity, displacement, acceleration, and force, while a scalar is a quantity that has only magnitude. Example of scalar are speed, distance, power, and work. Without us realizing it, vectors are actually widely applied in our daily lives. Therefore, through these tasks, we can find out how vectors can help us solve problems that arise. Vector application in real life. In navigation, vectors are used to determine a location to be a target by a moving vehicle. This technology is called Global Positioning System or GPS, where the system informs the location of a vehicle and also the direction that should be taken to go to a desired destination, even in a moving vehicle. Therefore, vectors play a very important role in navigation. An example is a vector used for an aircraft navigation system. That's all from me. Now, I'm gonna give the chance to the next presenter to talk about his presentation.
Thank you, Hafiz. Now, I would like to present the mathematical solution that has connection with this topic. I want to present vector solution in architecture for the pyramid, but before I do that, I would like to explain the vector product first because it will be used in the solution. Vector product is also known as cross product. In mathematical context, vector product is used to calculate the area of triangle and parallelogram. That's why we apply this in architecture, like find the area of the pyramid. So this is the example of vector product that is applied in architecture, like finding the area of the pyramid. I only want to know this part, so I label it as OAB. So here, for example, vector OA equal to negative 4i minus 4j minus 3k. And here is vector OB equal to 5i plus 2j plus 3k. To find the area, we can use the formula here 1 per 2 times vector OA across with vector OB. First, we need to know the value of this. So to solve that, vector OA times vector OB equal to, this will be 3 times 3, meaning that it will look like this. It will have 3 rows and 3 part of here. So the first row, we will put what we see here, which is I, J, K. Same with this I, J, K. So here at the first, we will put I, J, K. At the second row, we will see at the vector OA value, which is negative 4, negative 4, negative 3. So we put it here -4, -4, -3 for vector OA, and same to this, the last row is for the vector OB, which is 5, 2, 3. After that, we will write it like this: bracket I minus bracket J plus bracket K. To know what to put in here, for example, at the bracket I, we will hide this part and only write what's left, like this. So this is I, we'll hide this, and this is what will remain. So -4, 2, -3, 3. And do the same to the rest. After complete that, we will multiply them crossly like this. This will multiply to this, and this will multiply to this. So solve it. -4 times 3, -12, minus 2 multiply with -3, -6. And do the same to the rest. After finish that, just solve it like this. To know the value of this, we just put this, each of this into this. And just solve it like that. So this is the value for this. So now we can find the area of the triangle. So we solve it here. 1/2 times with this 13.75, and then we got 6.87 unit square. So that's the example of mathematical solution in vector. Next, I will give a chance to ID to give a conclusion.
In conclusion, the vector quantity is a physical quantity which needs both magnitude and direction to define it. The scalar quantities explain one-dimensional quantities. On the other hand, multi-dimensional quantities are explained by vector quantity. The scalar quantity changes only when there is a change in their magnitude. Thank you for being such a wonderful audience. It was a great pleasure for us. Thank you.